So astronomers then look at actually the shape of the spectral lines, whether they are sharp or broadened, and they divide the stars into so-called luminosity classes, not to be confused with spectral classes. So let me show you what I mean by different luminosity classes. Okay, so here is the HR diagram indicating different luminosity classes of stars. So here is the main sequence. It's one luminosity class. Then it turns out that the giants can be divided further into several luminosity classes: bright supergiants 1A, supergiants 1B, bright giants 2, giants 3, subgiants 4, and also white dwarfs form a separate luminosity class. So by looking at the details of the spectrum of a star, you can then find out to which luminosity class it belongs, whether it's somewhere on this line, whether it's on this line, or which one. So suppose you find by looking at the star that it belongs to the main sequence luminosity class, that it is here, okay? Then you measure its temperature by either using the Wien's law or by determining its spectral class, right? So you measure the temperature, you've established that it is a main sequence star, so you know it must be represented by this point here. And then you just read off what its luminosity is from the HR diagram, okay? So by using this method, by determining the luminosity class of the star and the HR diagram, you can find out the luminosity of the star, of course, by measuring its temperature or spectral class. Once you know the luminosity of the star, you measure its brightness, and then you use that relationship between luminosity, distance, and brightness to determine the distance of the star. And this method of determining the distance is called spectroscopic parallax. So what you do, you measure the temperature of the star, that is, find its spectral class, whether it's O, B, and so on, all way to M, and the temperature is decreasing in this direction. Then, from its spectrum, determine its luminosity class. Okay, once you know the luminosity class, say it's a main sequence star, and by knowing its temperature, then you can read off on HR diagram, right? So here is the main sequence. So you measure the temperature of the star, and then you can read off its luminosity. And once you know the luminosity of the star, then by measuring its brightness, you can determine its distance. Okay, so that is what spectroscopic parallax is. It's a way of determining the distance to the star by using the HR diagram, and of course by measuring its spectral class and its luminosity class.